Our next presentation will be entitled Setting Estuary Nutrient Criteria in Florida, Lessons Learned, Part 2. Hats off to Jay Laveroni, who is here today from the Sarasota Bay Estuary program. He'll be substituting for Tony Janake, who had a conflict and couldn't attend, so let's turn it over to Jay.
Thanks for a warm introduction. That's it. Yes, I was notified this morning that Tony is suffering from a really bad back, and knowing that Kristen working in Ralph, also I know this thing is suffering from a really bad back. Just picture of my head with them laying on the bed, watching so loud. We need it this time of day. But I'm happy to do my best to delay lunch. Taking the opportunity to talk about lessons learned from setting nutrient criteria. Looking at the abstract, I see this is part 2. So I didn't know I would do a part 1 was, but I'm thinking that perhaps, like any Hollywood blockbuster movie, you don't put out a sequel unless the original was really wonderful. So let's assume that this that part 1 was sequel co-authors, as you can see, are the executive directors for each of the 3 local national estuary programs. As well as, it's not on here, but it is on the abstract, Errol Twainer from the Department of Environmental Protection, which is
host.
Which is also a instrumental in this discussion. So what we're going to do is talk about the lessons that we learned as the 3 estuary programs when we got involved in assisting the state and the EPA in developing numerical nutrient criteria for our estuary waters. So I'm going to go through this presentation with you, just see how it goes. The Clean Water Act, as this slide clearly shows, the water quality standards. Each state was required to assign designated uses for all the water bodies and criteria that would maintain water use to obtain those designated uses. The state of Florida has designated uses for all the water bodies. Estuary waters are free marine, which means that they are able to support recreational fishing and swimming. Up until recently, the water quality standards were narrative in nature, stating that you have to maintain there's a particular language for it, diversity of fish and wildlife, fish and animals. So in 1998, the EPA issued a strategy to encourage states to adopt numeric standards. In 2010, the EPA determined that the need for numeric nutrient criteria were necessary for this was promulgated by some legal suit that were filed, and this whole process took place for better or worse, for quicker or longer, in the context of legal arrangement with the feds, litigants, and the state. So all this is going on under a very strict timeline in Florida that's promulgated by this lawsuit. While this was happening, the 3 estuary programs, which all have comprehensive conservation and management plans, a large part of that plan is to protect the water quality and the resources of the estuaries, individually and collectively decided that we have a lot at stake, and we have a lot, and we're well positioned to be of assistance in the development of numeric criteria for estuaries. Now, at the same time, there were criteria that were being promulgated, were being developed for freshwaters throughout the state of Florida, including streams, lakes, the springs, and South Florida waters. A much more complicated process in my mind, and some people's minds have gone through this, than the estuary criteria development was. Different time frames, different schedules for completion of these different sets of numeric nutrient criteria. The freshwater criteria were initiated before the estuary criteria, but we saw estuary programs an opportunity to play a vital role in the approaches that we and the state and EPA have taken toward developing nutrient criteria, there were three basic approaches. One of which was the reference condition approach, which was used with freshwater streams, whereby you try and find a pristine or non-impacted water body, assess its water quality, assess its biological endpoints, and determine a level of attainment that you would like based on a reference condition.
Host.
We found that with respect to estuaries that there were no reference estuaries throughout the state that would be used for the rest of the estuaries. Another approach was mechanistic modeling, and in fact, the EPA, while they were working very feverishly to develop criteria for estuaries, were using the mechanistic model approach. It took a while for us to actually begin working with them to see what they were doing, how their approaches were going, because they were under strict time frame. These mechanistic models really require good inputs to the model, and in reviewing some of the model, we realized that a lot of the confounding conditions or inputs into the models were not up to date. For instance, I remember in Sarasota Bay, for instance, they had their model with midnight pass as pass. In fact, it close to 20 years. So, as well, while you use the mechanistic model in a large-scale approach, there were some shortcomings to that applying it to local conditions. And then the other approach is numerical. Then you have data, use the data, run analyses, and see if those data can help you derive numeric nutrient criteria that would be protective of your conditions. And that is the approach that the estuary programs use. And the reason being is because we have very effective, very comprehensive long-term water quality monitoring programs with which to glean the data from and to run statistical analysis. We have excellent seagrass data, which was the biological endpoint or the resource that we were using to base the criteria on. So we had data, we had local scientists, and what better way to approach this than to use those factors in determining the criteria. As I mentioned, the reference approach, we could not find, state defense could not find one approach that would work well with them all. In our case, we did find the empirical approach would work quite well. So, I guess I got ahead of myself, but this shows a schematic or a flow diagram of the approaches that are taken. First of all, we developed seagrass targets. Each of our estuary programs, as you heard, Charlotte Harbor, well known as 14 segments in Charlotte Harbor. Sarasota Bay has 5 segments, and Tampa Bay has 5 or 6 or 7 as well. So we developed segment-specific seagrass targets. We developed water quality and core field targets that would support those seagrass targets. Developed loading estimates, and then we modeled stress responses by using regression analysis for that work. And we could let me see. But we basically used a variety of different statistical approaches to find the best model statistical model that would relate chlorophyll water quality to our seagrass targets. Numeric nutrient criteria indicators. Seagrasses, as I've already mentioned, was the natural resource that we wanted to protect here. We also looked at DO to see if there were any implications for liquefied oxygen in our systems, and the occurrence of harmful aqua blooms that was related to nutrients as well. One of the things that we had to make sure of was that we established the difference between what a target is and what a threshold was. And this is like indicates the target is more for our purposes a management goal where we wanted to, it was a desired chlorophyll concentration that we were trying to attain in order to ensure the protection of our seagrasses. A threshold was a level at which chlorophyll concentration is above this called detrimental effects. So I'm conditions. And with respect to setting the criteria were based on the threshold condition, which was a little bit higher than our target goals to attain. We also have, with respect to this slide, I guess I'll give a plug for the work that has ensued after our development criteria for estuaries. That is the fact that another body of water another water type that was not really well considered during this process between freshwater criteria and estuary criteria and coastal criteria that we're not discussing that today were our tidal creek systems, which each of our estuaries has quite abundant variety and tidal creeks. Tidal creeks are unique in the fact that they support tertiary fisheries for snook in particular, and other important recreational and fish species. They often experience dissolved oxygen levels that might be considered harmful to these things, when in fact fisheries use these dissolved oxygen conditions as refuge for predators. In fact, I'll tell you this, yesterday we had the opportunity to sample South Creek in Sarasota County as a result of this ongoing work on this tidal creek study. And we sampled 3 locations along South Creek, the lower 2 portions which had sufficient oxygen in the water and accompanying fisheries on the side and the banks. When we got to our uppermost station, which had low salinity and very low salt oxygen, it was the only place that we found juvenile snook yesterday. So that was my first real in-field experience of seeing myself these things that we always talk about among ourselves and talk with regulators. And sometimes setting criteria that you don't have the end point in mind, you might set an appropriate criteria. So that was quite interesting yesterday. So we are extending this approach that we are using, that we used for the estuaries, into our tidal creeks. And with the goal of trying to understand the relationship between flow, nutrients, chlorophyll response to the water column and on the bottom, and habitat and fisheries. So I do have a poster that goes into that a little bit in the poster session this morning as well. We are currently just completed our 3rd bi-monthly sampling for that project. We will continue for the remainder of the year, so we'll be sampling through November of this year. And then we will analyze the data, do some statistics on it, see if we can develop some of these relationships to understand what appropriate criteria for nutrients in the tidal creeks might be. And also have to recognize that, like everything we're doing ecologically, we always have to understand temporal and seasonal variability in some of these things and understand what's appropriate for certain times of the year or not. Let's see here. Setting criteria for both nitrogen and phosphorus is challenging, when one is primarily fluidity, or when limitations vary seasonally. In our cases, we did develop criteria for both nitrogen and phosphorus, but for the most part, the one that we was focused on getting right, and some of the best regressions were done with our nitrogen concentrations as well as nitrogen loads in our systems. Concentrations versus flows. There was a decision regarding the expression of criteria as either concentrations or load. That's critical because it's very hard to manage concentrations, from what I understand. But certainly the only way you can manage is by managing the loads. So for the most part, we develop our criteria as loadings. And I know we have a hydrologically correct loads as well. In some respects, this is a legal decision, and I don't know much about that. But we have always been taking the approach in this whole process of letting the data decide the answers. So I think that's been really key to because the approach that we took and the results that we got were very defensible, and we really never got any fight back or concerns about what we were doing and how we were doing. So all across the board, our approach is never that much of an approach, because when we let data do the decisions. Things that one of the ways that we had to make a decision is how we were going to express the criteria. Arithmetic mean, geometric mean, or percent sequence. Not sure what to say about this other than the fact that I do believe that we use the geometric mean for statistical reasons as the most effective way to express our criteria. There's always confounding factors associated with these regressions, one of which is an example from our base Sarasota Bay, is the fact that the largest base segment for us is Big Sarasota Bay, and we found that there were some seasonal differences in this linear relationship between chlorophyll and nitrogen concentration, and so we had some covariates in there to better express the relationship and reduce the variability in that relationship. So the criteria for Big Sarasota Bay is actually seasonally dependent, which is kind of the first. I know people like, especially in dealing with regulations, you like a number to either apply with your seed, you have the follow up. If you don't, in this case, we've got the best way to express the concentrations to Sarasota Bay for the season. We'll always have non-progenic effects and events that will be a part of understanding compliance with these criteria. Not sure what else to say about that. But this slide shows that, for instance, hurricanes are abnormally uncharacteristic seasonally rainfall events. El Nino affects when you got droughts or excessive rainfall. It's going to have an impact. And these are not things that we regulate. And finally, lack of communication. I don't know what I'm going to say about this. I know in any relationship,